Urea plus NH3 gives NH minus NH2 C double bond O plus NH4 plus. Acetamide plus NH3 gives CH3 C double bond O NH minus plus NH4 plus. Sulfamide plus NH3 gives NH minus NH2 S double bond O plus NH4 plus. Sulfamic acid behaves as a dibasic in liquid ammonia. Sulfamic acid behaves as dibasic in liquid ammonia. However, it behaves as a monobasic in aqueous solution because NH2 group cannot donate a proton to water. NH2 S double bond OH plus H2O gives NH2 S double bond O minus plus H3O plus. Sulfamic acid is behaving as monobasic in aqueous solution. Acid-base neutralization. In aqueous solution, the process of neutralization of strong acid and strong base involves the combination of H3O plus from acid and OH minus from base to form practically unionized water. For example, the neutralization of hydrochloric acid and sodium hydroxide may be expressed as HCl plus NaOH, NaCl plus H2O, or H3O plus OH minus 2H2O. In a similar way, the neutralization of an acid and a base in liquid ammonia involves the base combination of NH4 plus ion and NH2 ion. NH4Cl plus KNH2 gives KCl plus 2NH3. NH4 plus NH2 minus in liquid NH3 gives 2NH3. There are many examples of amphoteric behavior in liquid ammonia. The compounds that dissolve both in acid and bases are called amphoteric substances. For example, in liquid ammonia, zinc amide shows amphoteric behavior analogous to that of zinc hydroxide in aqueous solution as a base. ZnNH2 twice base plus 2NH4Cl acid gives liquid NH3. ZnCl2 plus 4NH3. CF ZnOH twice plus 2HCl in presence of H2O gives ZnCl2 plus 2H2O. As an acid, ZnNH2 twice acid plus KNH2 base gives K2ZnNH24. CfZnOH plus 2KOH in presence of H2O gives K2ZnO2 plus 2H2O. Thus, acid gives NH2 plus ions and bases gives NH2 minus ions in liquid ammonia. These are termed as ammonobases and ammono acid. Reaction of ammono acid. Ammono acid is a substance that furnishes NH4 plus ion liquid ammonia. Ammonia halide, nitrate or thiocyanate are very soluble in liquid ammonia, giving NH4 plus ions and their concentrated solution act as amino acids. We know that acid give hydrogen with metal in aqueous solution. In a similar way, the amino acid react with alkali and other metals to give hydrogen. 2Na plus 2NH4Cl liquid NH3 gives 2NaCl plus 2NH3 plus H2. Mg plus 2NH4Cl gives MgCl2 plus 2NH3 plus H2. A saturated solution of ammonia nitrate in ammonia also dissolve many metal oxide similar to their behavior in aqueous acid. Na2 plus 2NH4Cl gives 2NaCl plus 2NH3 plus H2O. COO gives plus 2NH4Cl gives in liquid ammonia COCl2 2NH3 plus H2O. Solution of ammonium halide in liquid ammonia may be used as an acid in the preparation of silane and arsine. Mg2Si plus 4NH4Br in liquid NH3 gives silane plus 2MgBr2 plus 4NH3. Na3Es plus 3NH4Br in liquid ammonia gives arsine ESH3 plus 2NaBr plus 3NH3. Reaction of aminobases. Aminobase is a reaction which in liquid ammonia solution gives NH2 minus ion. The commonest base is potassium amide, which is much more soluble than lithium and sodium amides. The metal salts react with ammonobase to give amide nitride, which get precipitated in liquid ammonia. AgNO3 plus KNH2 gives KNO3 plus AgNH2 silver amide. PbI2 plus KNH3 gives PbNH lead amide plus Ki plus Hi. BiI3 plus KNH2 in liquid NH3 gives BiN bismuth nitride plus Ki plus 2Hi. 3HgI2 plus 6KNH2 gives Hg3N2 mercuric nitride plus 6Ki plus 4NH3. Precipitation reaction. Precipitation reaction involve double decomposition because of the difference in the solubility of different substances in water and in liquid ammonia. A large number of precipitation reactions which are not normally possible in water have been reported to occur in liquid ammonia. For example, silver chloride is precipitated in aqueous solutions as KCl plus AgNO3 gives AgCl plus KNO3. Similarly, a white precipitate of BaCl2 is produced when solution of silver chloride and barium nitride in liquid ammonia are brought together. 2AgCl plus BNO3 twice in liquid NH3 gives BaCl2 plus 2AgNO3. Lithium chloride may be precipitated by the reaction of ammonium chloride and lithium nitrate in liquid ammonia. NH4Cl plus LiNO3 in liquid NH3 gives LiCl plus NH4NO3. Iodide and bromide get precipitated when solution of various nitrates and ammonium halide in liquid ammonia are mixed together. ZnNO3 twice plus 2NH4I in liquid ammonia in liquid NH3 gives ZnI2 plus 2NH4NO3. SrNO3 twice plus 2NH4Br in liquid NH3 gives SrBr2 plus 2NH4NO3. Many metal sulfide can be precipitated in liquid ammonia by ammonium sulfate from the nitrate solution of the metal. NH42S plus 2AgNO3 liquid NH3 Ag2S plus 2NH4NO3. NH42S plus CuNH3 twice liquid NH3 gives CuS plus 2NH4NO3. NH42S CdNO3 thrice liquid NH3 gives CdS plus 2NH4NO3. Ammonolysis. The solvolysis reaction in liquid ammonia are called ammonolysis or ammonolytic reaction. These are analogous to hydrolysis reactions and involve the attachment of ammonium ion or amide ion to the reactant. For example, hydrolysis of SiCl4 occurs as SiCl4 plus 4H2O gives SiOH4 silicic acid. Similarly, ammonolysis of SiCl4 may be written as SiCl4 plus 8NH3 gives SiNH24 tetraamidocylene plus 4NH4 plus 4Cl minus. SiNH4 twice 4 gives in presence of 0 degrees Celsius SiNH4 NH4 twice NH2 twice 1200 degrees Celsius it gives Si3N4. It may be noted that in ammonolysis an atom or ion form a substance is replaced by a nitrogen containing ion or radical, example NH2 or NH. Some ammonolysis reactions are sulfuryl chloride plus 4NH3 gives sulfamide plus 2NH4Cl. SO2FOH plus 3NH3 gives SO2NH2 plus ONH2 plus NH4F. HgCl2 in presence of liquid NH3 gives HgNH2Cl. CCl4 in liquid NH3 gives CNH2 twice. GeI4 in presence of liquid NH3 gives GeNH twice. BCl3 in presence of liquid NH3 gives BNH twice thrice plus B2NH thrice. PCl3 in presence of liquid NH3 gives PNH2 thrice. In 0 degrees Celsius it gives P2NH whole thrice. SiH3Cl in presence of liquid NH3 gives SiCH3 thrice. CH3C double bond O NH2 in presence of liquid NH3 and NH4Cl gives CH3C double bond NH2. VOCl3 in presence of liquid NH3 gives VONH2 thrice. C2H5COOCH3 plus NH3 gives C2H5 CONH2 plus CH3OH. In excess of liquid ammonia, the ammonolysis of TiCl4 occurs in steps as TiCl4 in presence of liquid NH3 gives TiCl3NH2. In liquid NH3 it gives TiCl2NH2 twice. In liquid NH3 it gives TiClNH2 thrice. In liquid NH3 it gives TiNH2 4. When organic halide which undergo slow ammonolysis are ammonolyzed at the boiling point of liquid ammonia, mixture of primary, secondary and tertiary amines are obtained. Rx plus 2NH3 gives RNH2 primary plus NH4X. Rx plus RNH2 plus NH3 gives R2NH secondary plus NH4X. Rx plus R2NH plus NH3 gives R3N tertiary plus NH4X, where X is equal to chlorine, bromine, iodine, and fluorine. Though ammonia molecule is basic and has strong tendency to accept proton and therefore it will act as base. However, towards very strong bases, it acts as proton donor. Example on this type of ammonolysis reaction are NaH plus NH3 gives NaNH2 plus H2. NaCH3 plus NH3 gives NaNH2 plus CH4. Na2O plus 2NH3 gives 2NaNH2 plus H2O. Number 4. Complex formation reaction. Many complex formation reactions in liquid ammonia are reported which are similar to reaction occurring in the aqueous system. For example, zinc nitrate react with potassium amide to form insoluble zinc amide which dissolve in excess of amide due to formation of complex compound of zinc. ZnNO3 twice plus 2KNH2 in liquid NH3 gives ZnNH3 twice insoluble plus 2KNO3. ZnNH2 twice plus 2KNH2 in liquid NH3 gives K2ZnNH24 soluble. This reaction is analogous of reaction of zinc nitrate with sodium hydroxide in water. ZnNH3 twice plus 2NaOH in presence of H2O gives ZnOH twice insoluble plus 2NaNO3. ZnOH twice plus 2NaOH in presence of H2O gives Na2 ZnOH4 soluble. Some other example reaction in liquid ammonia are CuCl2 plus 4NH3 in liquid NH3 gives CuNH34 Cl2. AgCl plus 2NH3 in liquid NH3 gives AgNH3 twice Cl. CrCl3 plus 6NH3 gives CrNH36Cl3. Number 5. Formation of ammoniates. Just as water form hydrate, ammonia also form ammoniate with many inorganic salts. In this compound, the ammonia molecules are coordinated to the cation. Some typical ammoniates are BF3 plus NH3. In liquid NH3 gives BF3 dot NH3. MgI2 plus 6NH3 in liquid NH3 gives MgI2 dot 6NH3. SiF4 plus 2NH3 in liquid NH3 gives SiF4 plus dot 2NH3. NiI2 plus 6NH3 gives NiI2 dot 6NH3. Redox reaction. Liquid ammonia acts as an excellent medium for redox reaction. In liquid ammonia, the oxidizing action of strong oxidizing agent is weaker than in water or solution. For example, HNO3 in liquid ammonia does not act as an oxidizing agent. Similarly, KMNO4 in liquid ammonia acts as a very weak oxidizing agent. On the other hand, the reducing agent showed increased reactivity. For example, alkali metals act as very powerful reducing agent in liquid ammonia. For example, sodium metal in liquid ammonia reduce CuI to Cu, KMNO4 to K2MNO4, etc. CuI plus Na, Cu plus Nai, KMNO4 plus K in liquid NH3, K2MNO4. Number 7. Solution in liquid ammonia. The dielectric constant of liquid ammonia is low. Therefore, it is expected to be a poor solvent for ionic substances. Amongst the inorganic compound, all ammonium salt, nitrate, thiocyanate, and iodide are soluble in liquid ammonia. Oxide, hydroxide, carbonate, phosphate, sulfate, and most of the sulfide are insoluble. Most of the fluoride are insoluble in liquid ammonia, and the solubility among halides increases as fluorine, chlorine, bromine, iodine. Most of the iodides are soluble. Calcium and zinc chloride, which are extremely soluble in water, are quite insoluble in ammonia. Organic compounds such as halogen compound, alcohol, ketone, ester, simple ether, phenol, amines in nitro compound, etc. are readily soluble in liquid ammonia. Aromatic hydrocarbons are sparingly soluble. Paraffin and benzene are not soluble. Amongst the solvent element, metals like Mg, Al, Zn, Ca, La, Ce, Mn, etc. are only slightly soluble in liquid ammonia. Alkali metal and alkaline earth metal are highly soluble in liquid ammonia. These form very interesting soluble and are discussed below. Non-metals like SpISe are soluble in liquid ammonia. Solutions of alkali metal in liquid ammonia. The most striking property of liquid ammonia is its ability to dissolve alkali metal. The resulting solution are blue and extremely good electrical conductor. The important characteristic of alkali metal solutions are these are blue in color and the color is independent of the metal dissolved. When the concentration of the metal is increased, the color changes to bronze and shows metallic appearance. These solutions are conducting and show strong reducing properties. These solutions are paramagnetic and the paramagnetic character decreases with increasing concentration. If the reagent are pure and dry, sodium solutions in liquid ammonia are stable and can be preserved for several days. When alkali metals are dissolved in liquid ammonia, they ionize to give metal ion and valence electron as Na gives Na plus electron. Both the alkali metal ion and electron become solvated by ammonia molecules Na plus NX NH3. NaNH3X plus ammoniated cation. Electron plus YNH3, electron NH3Y minus ammoniated electron. The complete reaction may be written as Na gives Na positive NH3X plus electron NH3Y minus. The ammoniated electrons are responsible for blue color of the solution. This is due to the absorption of visible light ammoniated electrons. The electrical conductance is also due to the ammoniated cations and ammoniated electrons. The conductivity of metal in liquid ammonia is comparable to that of an aqueous solution of a typical ionic compound. As the concentration of the solution is increased, the ammoniated cations and electrons associate result in a decrease of conductivity. Very dilute solution of alkali metals in liquid ammonia are metastable and when catalyzed they undergo decomposition. NH3Y minus Fe2O3 gives NH2 minus plus half of H2 plus Y minus 1 NH3. As the concentration of metal increases, the blue color changes to bronze and finally the blue color disappears altogether. This is due to the fact that impurities such as iron oxide catalyze the conversion of metal into amide. On evaporating the alkali metal ammonia solution, alkali metal can be recovered. The strongly reducing character of this solution is due to the presence of readily available electron. The important application of alkali metal solution in organic chemistry is the reduction of many function group and unsaturated compound as already studied. The liquid ammonia is a thoroughly studied non-aqueous solvent. Some of its advantages and disadvantages as a solvent are given below. Advantage of liquid ammonia as a solvent. The dissolution of alkali metal without chemical reaction is one of the greatest advantages of using liquid ammonia as a solvent. The dissolved alkali metal can be removed from solution by evaporation. 2. The alkali metal solution are strong reducing agent even stronger than hydrogen. Number 3. Ammonium salt dissolved in liquid ammonium act as amino acid and these find application in preparative chemistry. They can be used to prepare silane, arsen, etc. The tendency of solvolysis is less in liquid ammonia than in water. Disadvantage of liquid ammonia as a solvent. The liquid range for liquid ammonia is from minus 33.3 degrees Celsius to 77.7 degrees Celsius. Therefore, a low temperature or high pressure is necessary while working with liquid ammonia. Number 2. Liquid ammonia has an offensive odor. Therefore, it requires special technique to use it as solvent and as a reaction medium. Number 3. Liquid ammonia is a hygroscopic in nature, hence all the reactions are able to carried out in sealed tubes, which out of NH3 or H2O undergoes more ionization. Answer: H2O. Complete the following reaction: PbI2 plus KNH3. Question number 6. How do the following solute behave in ammonia as an acid or base? KNH2 or NH4NO3. KNH2 is base, NH4NO3 is acid. Now our topic is liquid sulfur dioxide. Liquid sulfur dioxide is a non-protonic solvent or aprotic solvent because it does not contain any hydrogen atom. It is also one of the important non-aqueous solvent and has been widely used in industry. Under normal condition of temperature and pressure, sulfur dioxide is a gas, but it can be readily liquefied and is easily maintained in the liquid phase. It has a wide liquid range, minus 10 degrees Celsius to minus 75 degrees Celsius, and it can be used as a solvent. It can be easily purified by passing the gas through sulfuric acid and through PTO5 to remove the traces of water. Its dielectric constant is small and therefore is a good solvent for covalent compound. The characteristic physical properties of liquid sulfur dioxide are given in table 5. Property and value. Freezing point minus 75.46, boiling point minus 10.02, density 1.46, viscosity 0.428, dielectric constant 17.4, dipole moment 1.6761. Specific conductance ohm inverse centimeter inverse 4 into 10 raised to power minus 8 at minus 10 degrees Celsius. Structure of sulfur dioxide molecule. Electron diffraction studies have shown that sulfur dioxide in gaseous phase has the angular structure as shown ahead. Solubilities of compound in liquid sulfur dioxide. Among the inorganic compound, iodide and thiocyanate are most soluble. In case of alkali metal halide, the solubilities are in order. Mi is greater than Mbr, Mbr is greater than Mcl, Mcl is greater than Mf. The union-negative polyatomic anions such as ClO4-, NO3-, BF4-, etc. are generally more soluble in liquid SO2. Salt of multi-negative anions such as SO4-, SO3-, S2-, O2-, etc. are practically insoluble. Many of the ammonium, thallium, and mercuric salt are soluble. It is an excellent solvent for covalent compound. Many covalent substances like halogens, interhalogen, phosphorus halide, oxyhalide of sulfur, phosphorus, etc. and halide are soluble in it. Metals are insoluble in liquid SO2. Among the inorganic compound, aromatic hydrocarbon and alkene have very high solubility in liquid SO2. In comparison to saturated hydrocarbon, pyridine, quinoline, ether, halogen derivative, and acid chloride also dissolve in liquid SO2. Many compounds dissolve in a liquid SO2 due to solvent formation. For example, C5H, for example, Ki.4SO2, Ci2.4SO2, KCN.4SO2. Many donor molecules also form stable solvent with SO2. For example, C5H5N.SO2, C6H5OCS3.SO2, BF3.SO2, etc. Autonization of SO2. Pure SO2 is a poor conductor of electricity, though it is below to autonize as shown. The thionyl ion is analogous to the hydronium ion, and ammonium ion and sulfite ion correspond to hydroxyl and amide ion of the aqueous and ammonium system respectively. Reaction in liquid sulfur dioxide. Some important chemical reaction in liquid sulfur dioxide are discussed below. Acid-base reaction. Liquid SO2 undergoes ionization as 2SO2 gives SO2 plus SO3 2 minus. According to solvent system concept of acid and bases, the compound which give thionyl ions in solution of SO2 would behave as acid, whereas compound giving sulfite ion liquid SO2 would act as bases. For example, compounds such as SOCl2, SOBr2, etc. act as acid in liquid SO2. SOCl2, thionyl chloride in liquid SO2 gives SO2 plus 2Cl minus. If some acid SOCl2 is added to the solid complex solution, the aluminum sulfide precipitate 2NCS343 ErSO3 thrice plus 3COCl2 in liquid SO2 gives 6NCS34Cl plus 6SO2 Al2SO3. This reaction is also analogous to reaction in water. NaAlOH4 plus HCl gives H2O, NaCl plus H2O plus AlOH thrice. Similarly, in salt of zinc 2 show amphoteric behavior in liquid SO2. ZnCl2 plus K2SO4 in liquid SO2 gives ZnSO3 plus K2KCl. ZnSO3 plus K2CSO3 gives K2ZnSO3 twice. Number 2, solvolytic reaction. Solvolytic reaction in liquid sulfur dioxide are not as common as they are in protonic solvents such as NH3. Some reactions are given below. Ammonium acetate is solvolized in liquid SO2. 2CH3 double bond ONH4 plus 2SO2 gives NH4 twice SO3 plus 2CH3 CO twice double bond O SO. CH3 C double bond O twice SO gives SO2 plus CH3 C double bond O twice O. This reaction is analogous to the reaction of ammonium acetate in water. NH4 O C double bond O CH3 plus H2O gives NH4OH plus CH3COOH. Certain covalent halides such as PCl5, PBr5, UCl5, ASCl5, WCl6 undergo solvency in liquid SO2 in seal tubes. PCl5 plus SO2 gives POCl3 plus SOCl2. PBr5 plus SO2 gives POBr3 plus SOBr2. UCl6 plus SO2 gives CO2 Cl2 plus 2SOCl2. ASOCl5 plus SO2 gives ASOCl3 plus SOCl2. WCl6 plus SO3 liquid gives WOCl4 plus SOCl2. ZnC2H5 twice plus 2SO2 gives liquid SO2 gives ZnSO3 plus C2H5 twice SO. Main binary halides such as SbCl3, SbCl5, SbCl4, SnCl4, BCl3, SCl2, SCl4 plus MoCl6, etc. do not undergo solvolysis in liquid sulfur dioxide. The formation of solvents, that is, addition of compounds with the solvent, is also known. Typical example of solvent are NaI.4SO2, RBI.4SO2, KBr.4SO2, CI.4SO2, Bi2.4SO2, SRI2.4SO2, AlCl3.2SO2. Number 3, precipitation reaction. A large number of precipitation reaction can be carried out in liquid sulfur dioxide due to selective solubility of compounds. The precipitation of several insoluble compounds in liquid sulfur dioxide can be carried out by treating them with soluble compound in sulfur dioxide. Some of these reactions are SbCl3 plus 3LiI. Liquid SO2 gives SbI3 plus LiCl. PbF2 plus LiSO4 in presence of liquid SO2 gives PbSO4 plus 2LiF. AlCl3 plus 3NaI in presence of liquid SO2 gives 3NaCl plus AlI3. Bi2 plus Zn2CnSO4 in presence of liquid SO2 gives BaCN6 twice plus Zni2. Thionyl derivative can be easily prepared in liquid SO2 by the action of thionyl chloride. 2CH3COOAg plus SOCl2 in liquid SO2 gives 2AgCl plus SOCH3COO twice thionyl acetate. 2Ki plus SOCl2 in presence of liquid SO2 gives 2KCl plus SOI2. 2NH4SCN plus SOCl2 in presence of liquid SO2 gives 2NH4Cl plus SOSCN twice. Number 4, complex formation reaction. A large number of complex ion formation liquid sulfur dioxide have been reported. For example, the solubility of iodine in liquid sulfur dioxide is greatly increased by the addition of potassium rubidium iodide. This is due to the formation of the complex Ki3 or RbI3. Ki plus I2 gives Ki3, Rb plus I2 gives RbI3. Similarly, the increase in solubility of cadmium iodide and mercury iodide in liquid sulfur dioxide is attributed to the formation of complexes. CdI2 plus 2Ki gives K2CdIO4. HgI2 plus 2Ki in presence of liquid SO2 gives K2HgI4. AlCl3 react with SO3 2- ions to form a precipitate of Al2SO3 thrice, which redissolves in excess of SO3 2- ions, forming the complex ion AlSO3 thrice 3-. 2AlCl3 plus 3SO3 2- gives Al2SO3 thrice plus 6Cl-. Al2SO3 thrice plus 3CSO3 2- gives 2AlSO3 thrice 3-. Soluble complex ion. Similarly, SbCl3 plus 3KCl gives K3CbCl6. SbCl5 plus KCl gives KbCl6. SbCl5 plus NOCl gives NOCbCl6. SbCl5 plus CH3COCl gives CHCOCbl6. SbCl6. SbCl5 plus CH3NO NCl gives CH3N CH3 4 and CbCl6. Number 5. Organic reactions. A large number of organic reactions have been carried out in liquid sulfur dioxide because organic compounds are soluble in it and it is a relatively inert solvent. Some common examples are: number 1. Sulfation of aromatic hydrocarbons by sulfur trioxide or chlorosulfuric acid. C6H6 plus SO3 in presence of liquid SO2 gives C6H5SO3H. C6H6 plus ClSO3H in presence of liquid SO3 gives C6H5SO3H plus HCl. Number 2. Liquid SO3 has also been used as solvent for Friedel-Crafts type reaction. In this reaction, AlCl3 is used as a catalyst which is highly soluble in liquid SO2. C6H6 plus TC5H11Cl, AlCl3 liquid SO2, TC5H11C6H5 plus HCl. C6H6 plus C6H5COCl gives AlCl3 in liquid SO2, C6H5OCOC6H5 plus HCl. Number 3. It is also used as a solvent for the addition and substitution of bromine reaction. Styrene plus Br2 in liquid SO2 gives benzene CH2Br Br. Phenol plus Br2 in liquid SO2 gives benzene OH Br plus HBr. Number 6. Sulfur dioxide of crystallization. These reactions are also called solvation reaction. Like water and ammonia, salts having sulfur dioxide of crystallization have also been observed. Some examples are NaI.4SO2, Ki.4SO2, Li.4S2SO2, Bai2.4SO2, AlCl3.2SO2, KCNS.SO2. These are found with the highly soluble salts and are analogous to hydrates. 7. Redox reaction. Though gaseous sulfur dioxide behave both as oxidizing and as reducing agent, liquid sulfur dioxide does not show any marked reducing or oxidizing tendency. It simply acts as medium for certain redox reaction. For example, iodine is liberated from Ki in the presence of SbCl5 in liquid sulfur dioxide. 6 Ki plus 3 SbCl5 gives 2 Ki3 SbCl6 plus SbCl3 plus 3I2. 2 Ki plus 2 Fe3Cl3 gives 2 FeCl2 plus 2 KCl plus I2. Some special feature of liquid SO2 as a solvent. Liquid sulfur dioxide possesses some special advantage and over other solvent as a reaction medium. Some of these are: it has low boiling point and this allows its easy evaporation and therefore removal from the reaction in mixture. It has low melting point and therefore it allows reaction to be carried out at low temperature. Liquid SO2 is an inert solvent. It has unusual solvating power for both covalent and electrovalent compound. It is a better medium for covalent compound like hydrocarbon and is used for the purification of some petroleum product. It is used as a diluent for the superacid medium HSO3F SPF5, which helps in reducing its viscosity without affecting its acidity. Thank you.